Hi, thank you for tuning into our stream tonight. My name is Alex Gonzalez, and I am a civil engineering major at Rose-Hulman Institute of Technology. Here at AskRose, we provide homework help for things like math and science for middle and high schoolers, and today we're going to be talking about how to do dimensional analysis. So dimensional analysis is a way of converting one type of units very simply to another type of units, and you do this by using equivalent fractions. So basically that means using something that equals 1 except in fraction form. So, you know, the way that we think about 60 seconds equaling 1 minute, if we put that into a fraction, it still equals 1. So if you multiply that by something of different units, you will get something of different units that still equals the same thing. So we care about dimensional analysis because there are a lot of times where you measure something in a certain type of unit, but you need it in a different type of unit. For example, if you're doing a physics problem and it gives you the speed that a car is going in miles per hour, but you need it in meters per second, you need to convert the units from miles per hour to meters per second, and you could do that with dimensional analysis. It's used for things like chemistry, physics, biology, a lot of different sciences, and a lot in math as well. So an example that we have here is convert 2,358 grams to pounds. So what I like to do for these types of problems is write out 2,358 grams over 1. And so in order to change this to grams, you have to multiply it by an equivalent fraction that gets you to the unit that you want. So the conversion for 1 pound to grams is right down here. We have it as 1 pound equals 454 grams. So since we have grams in the numerator here, we want to get rid of grams and add a different unit. So we could put 1 pound over here over 454 grams. So the reason this works is because 1 pound is exactly equal to 454 grams. So 1 pound over 454 grams is 1. You're not really multiplying it by anything. You're multiplying it and you're getting the same equivalent answer, but in a different form. So here, our grams cancel and we're left with just pounds. Can you pull up the calculator really quickly to find what the answer should be? Just divide what's left over basically, so multiply everything that's in the numerator, divide everything that's in the denominator, and then what you get will be just one number. So here we don't have anything to multiply in the numerator, so we're just going to divide the 454. And that gives us about 4.19 pounds. 5.19 pounds. So convert 651 grams to ounces. So this is kind of a similar example where we're dealing with weight, but again, different units. And for this one, it's not just one conversion that we have to do, because sometimes you have to do multiple conversions in order to get to your final answer. You can't just say, I'm going to convert a whole day down to seconds, because you have to consider how many hours are in a day, how many minutes are in an hour, and how many seconds are in the hour. So sometimes you have to do multiple steps in order to get it down to the units that you want. So here we're starting out with 651 grams. I like to put it over 1 just so that way we start out with a fraction. And we are going to get rid of the grams. So we want grams down here, and we're going to change it to pounds. So we have 1 pound is equal to 454 grams. But that gets us to pounds, and we're trying to get to ounces. So we have to do one more conversion. So now we want to get rid of pounds. And that's equal to 16 ounces. So here we got rid of our grams, changed it to pounds, changed our pounds to ounces, and now we have it simplified down to get our ounces. So multiply everything that's in the numerator, divide by what's in the denominator, and you'll get your final answer. So 651 divided by 454 times 16 gives us 22.94 ounces. So this one we actually had to go to a larger unit of pounds and then down to a smaller unit of ounces, because there isn't really a conversion from grams to ounces that we use, since there are two very different types of measurements that you would do. So for another example, a beaker has 367 milliliters of water. What is the volume in quarts? So here we have a different type of example, because instead of changing from one type of unit to another, we have to change the unit that we have to the standard unit and then to a different type of unit. So in your science classes, you may have learned that 1 liter is equal to 1 times 10 to the third milliliters. So basically 1,000 milliliters is equal to 1 liter. I can write that out here too. 1,000 milliliters is equal to 1 whole liter. So instead of just changing over from milliliters to quarts, we don't want to do that. We want to change from milliliters to the standard unit of liters and then change it to quarts. So we'll start out with 367 milliliters over 1. We want to get rid of milliliters, so 1,000 milliliters is equal to 1 liter. And we want to get rid of liters, so and change it to quarts, so 1 quart is equal to 0.946 liters. So here we've gotten rid of our milliliters, changed it to the standard unit, and now we're changing from the standard unit to our desired unit of quarts. So divide by everything we have in the denominator. We have 367 divided by 1,000 divided by 0.946. And this gives us 387.94 times 10 to the negative 3 quarts. So us getting an answer that is in scientific notation just means that it's a little bit too small of a number for us to want to write it out like that. This would also be equal to 0.387 quarts. So in a different example, which is kind of like what I was talking about earlier with in a physics example, you want to change from miles per hour to meters per second. This example says, if you are traveling at 65 miles per hour, what is your speed in kilometers per second? So here we have a couple of different things that we want to do, because instead of like the other ones where we have just one unit in the numerator, we actually have 65 miles for every 1 hour. So here the unit is not miles per hour necessarily, it's how many miles are you getting per hour. So it's two different units that are being measured with respect to one another, as in how many miles you are traveling in a specified amount of time, So you have 65 miles for each hour that you're traveling. So the first thing we want to do is deal with our hours. We want to change that to seconds. So because that's in the denominator, instead of dividing by our conversion factor, this time we want to multiply it. We want our conversion factor of hours to be in the numerator. So 1 hour is equal to 60 minutes. We want to get that down to seconds, so we want to get rid of minutes and do 1 minute is equal to 60 seconds. So now we have our denominator down to 60 seconds, but we still have to change miles to kilometers. Well, first we want to change miles to meters, or sorry, miles to feet, by getting rid of our miles and multiplying by what 1 mile is equal to in feet, which is 5,280 feet. Now we want to get rid of our feet, so 3.281 feet is equal to 1 meter. And we're still not done yet because right now we have meters per second if we were to complete this calculation, but we want our final answer to be in kilometers per second. So put meters down here, kilometers up here. 1 kilometer is equal to 1,000 meters. So now we'll go through all our calculations. We'll do 65 divided by 60 divided by 60 again times 5,280 divided by 3.281 divided by 1,000 gives us an answer of 29.056 times 10 to the negative 3 kilometers per second. So for this answer, it actually might make more sense to leave it in terms of meters per second, because that way you would get just 29.056 meters per second. But sometimes we don't necessarily want to do things based on what's easiest. Sometimes we want to do them just based on the answer that we were given. So in this example, we are instead converting from miles per hour to nanometers per second. So instead of going up 2 kilometers, we're going down to nanometers per second. So I'm not going to do the entire calculation again since we just found what it was, but instead I'm going to use our answer of 29.056 times 10 to the negative 3 kilometers for every second. And then I'm going to start doing the conversions that way. So our seconds is good, our time we don't have to change that at all, so we're just going to change kilometers to meters. 1 kilometer is equal to 8,000 meters. So now we're at the standard unit for that length, for that type of measurement of length, and we're going to change it to 1 times 10 to the negative 9 meters is equal to 1 nanometer. So here you can see we already did all of these calculations to get us to where we would be in kilometers per second. So if we had gotten this problem initially, the only thing we'd be doing differently is instead of going from meters to kilometers, we'd be going from meters to nanometers. Start doing our simplifications. We are going to multiply by 1,000 and then divide by 1 times 10 to the negative 9. And this gives us an answer of 29.056 times 10 to the 9 nanometers per second. Which makes sense if you think about it, because we went from times 10 to the negative 3 multiplying by 10 to the 3, so that should cancel out. And since we are dividing by 1 times 10 to the negative 9, that's the same as multiplying by 1 times 10 to the positive 9. And so, in the end, these two things cancel each other out, and we are just multiplying 29.056 times 1.10 to the positive 9. So for our next example, if you are traveling at 25 meters per second, what is your speed in miles per hour? So this one, we're going to go in a very similar direction that we did for the past couple ones, except we are going to be going bigger. We are going to be going 2 miles per hour. So we'll start out with, for every 25 meters, it's traveled in 1 second. And this time, instead of starting with the time, I'm going to start with the distance, with the length. So we're going to get rid of our meters, and we're going to change that to feet. For every 1 meter, just 3.281 feet. But we don't want our final measure of length to be in feet, we want it to be in miles. So 1 mile is equal to 5,280 feet. So now that we're in miles, we're happy with that, but we still have to change the seconds over to hours. So we do the opposite of what we did before. For every 60 seconds passes 1 minute, and for every 60 minutes passes 1 hour. So after doing all of the simplification, and this is a good way to check to make sure that you didn't put anything in the numerator when you should have put it in the denominator, is just go through and cancel out everything that gets canceled out. So here, meters gets canceled out, feet gets canceled out, seconds and minutes are canceled out, so the only thing left is miles over hours. So we do our calculations. We do 25 times 3.281 divided by 5,280 times 60 times 60. This gives us an answer of 55.926 miles per hour. So in this example, we want to convert minutes to fortnights, and we don't have a set number of minutes that we are working with. So before, we were changing a certain number of units to a different type of units, but this time we want to find out how many minutes are in 1 fortnight. So even though the question reads how many minutes are in a fortnight, we're actually going to be starting with fortnights and changing that over to minutes to see how many minutes are in there. So 1 fortnight, just gonna do over 1. And for every fortnight passes 2 weeks. So I'm gonna shorten this as FRT. I'm not sure what the regular shorthand for it is, but we're just gonna go with that. So fortnights cancel out. Now we want to get rid of our weeks and do for every 1 week that passes, 7 days passes. For every day, there are 24 hours. And if you're not sure how I'm deciding which units I'm going to use, basically you just kind of have to do a sanity check in your head and say, where am I starting and where am I getting to? Well, if you're starting at a fortnight, which is 2 weeks, that's how long a fortnight is, and you're getting down to minutes, you know that you are going to get smaller and smaller and smaller. And since I don't know in my head how many minutes are in 2 weeks, you just have to go down smaller and smaller using the conversions that you do know to get down to that eventual smaller unit. So in every 1 hour is 60 minutes. And you might know in your head that for every hour is 360 seconds or so on, but since we just want to get down to minutes, that's not something we're worried about. So weeks cancel out, days cancel out, hours cancel out, and we are just left with minutes. So if we go ahead and do this calculation, we have 1 times 2 times 7 times 24 times 60. So we get 20,160 minutes. So in this example, we have if the density of a box is 3.26 times 10 to the negative 4 pounds per cubic inch, what is the density in grams per cubic centimeter? So this one is different than the ones we did before because it's not dealing in measurements of time or distance or speed. It's dealing with density, which is a measure of volume over area. So here we have 3.26 times 10 to the negative 4 pounds per cubic inch. And we want to get that to grams per cubic centimeter. So this is similar in the ones that we did for speed, where you're dealing with two different units that you have to focus on in the same calculation. So first we're going to get rid of pounds and change that over to grams. So for every 1 pound, there is 454 grams. And this is where it gets a little bit tricky, because since we are dealing with a unit of, oh my goodness, I said that wrong. So instead of volume over area, it's mass over volume, which is different in the sense that your pounds measures how much stuff that you have in whatever it is that you're measuring. The cubic inches measures how much that stuff, how much space it takes up. Because this pencil, for example, is less dense than this calculator. Because this calculator, yes, it is a lot bigger, but that's not why it's more dense. It's more dense because it has a lot more stuff per area than this pencil has. So, because we're dealing with cubic inches and cubic centimeters, it's not just a straightforward calculation from inches to centimeters, because you have to consider that it is a volume and not just a measure of distance like a regular inch. What you can do is you can change the cubic inches to inches, but that's not exactly the same unit, so it doesn't make as much sense to do so. So instead what we can do is say that for every inch we have 2.54 centimeters. And we can cube both of these. So we do that because if you consider what an inch is in space, just 1 inch in distance, and you consider that in 3 dimensions, so 1 cubic inch, if you consider what that box looks like, you do the same thing for centimeters, then you find that you're multiplying that conversion factor of 2.54 by itself 3 times. So you're raising that to the third power in order to get it to 3D. So our pounds cancel out, cubic inches gets canceled out, and we are left with grams per cubic centimeters. Go ahead and do the calculations for this one. We got 3.26 times 10 to the negative 4 times 454 divided by 2.54 cubed, and we get 0.009 grams per centimeter cubed. For our next example, what is 0.0045 gallons in centiliters? So we have 0.045 grams over 1, and we're just going to approach this like we have been all of the examples so far. And we're going to get rid of our grams. Oh, sorry, not grams, gallons. Gallons. So we're going to get rid of our gallons and say for every gallon, there are 4 quarts. For every quart, there are 0.946 liters. And since we want our final answer to be in centiliters, for every liter, there are 100 centiliters. Gallons cancel out, quarts cancel out, liters cancel out, and we are left with centiliters. So we do 0.0045 times 4 times 0.946 times 100 gives us 1.7028 centiliters. So for this example, we are dealing with a chemistry problem. Determine the mass of carbon in 0.65 moles of this compound and determine the number of carbon atoms in the same sample. So this is kind of a two-part question. So the first part is asking, what is the mass of carbon in this many moles of this compound? The second part is asking, what is the number of carbon atoms in the same sample? So they're asking us to find 2 different measurements of carbon in the same sample. So we start out with moles of this compound, and we want to change that over to what the mass is, so we're going to get the answer in grams. So for every single mole of, actually wait a second, back up, so we'll put that over 1. So for this specific compound, we have 3 carbon atoms for every, let's see, we have 2, 3, and 9, so 14 atoms total. So we want to get rid of moles first. Do for every mole, there is 6.022 times 10 to the 23 atoms. Next, we want to say that there are 3 carbon atoms for every 14 total atoms in this compound, which I'm running out of space to write it as. We have, this is technically for the second part of the equation, but I prefer to deal with these types of compounds in terms of atoms first before going into the mass, just because that's how I remember it. And you can also check your periodic table as well for the atomic masses. So here we have the atomic mass for aluminum, for oxygen, and for carbon, the 3 different elements that we're dealing with in this one. So we'll do this calculation real quick. And oh, I wrote this one upside down because, see, this is where you can do your quick sanity check. So we get rid of moles, but here, instead of getting rid of the atoms, I accidentally wrote it upside down, and I'll fix that really quickly. Because we're not considering how many atoms there are per carbon atom, we want to know how many carbon atoms there are per molecule. So 14 atoms per 3 carbon atoms. So we do this multiplication and division, we get 0.65 moles times 6.022 times 10 to the 23 times 3 divided by 14. That gives us 8.388 carbon atoms. Oh, and this is times 10 to the 22. That's how many carbon atoms there are per in 0.65 moles of that compound. So if we're going from 0.65 moles to grams, then we want to convert this from moles to atoms. Let's see. And then get how many carbon ones there are per that, so same deal that we did before. And for every 1 molecule of carbon, or for 1 atom of carbon, that is, you can see it here on the periodic table, it is 12.011. 0.011 AMU, and that's atomic mass units. I said before that we were dealing in grams, but then I remembered that that's not what the question is specifying, it just asks for the mass. So doing that last calculation times 12.011 gives us 1.0075 AMU. Check that really quick. Moles cancel, atoms cancel, carbon cancels, left with AMU, and that is it. Thank you for joining our stream.